Hello, students. We are into the homework on 8.4, and as you can tell, I am excited. We get an opportunity to practice a little bit of algebra, but also do some things that may not involve algebra at all. So let's go through and see for 8.4b. I have 1 through 3, 5 through 7, 10 through 12, and number 17. So as it turns out, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 questions. So it's not actually a super long assignment, which for some of you is like, yay. So let's see here. First one is they give you a graph. The graph is y equals mx plus 5. And they say sketch the graph of these other ones on the same axes. Now, again, what they're saying is m is the same. So the slope would be the same for all of these graphs. So look at the slope as your guide. That's, again, I've tried to say that before. That's the rate of change. So whatever the rate of change is here, you want to use that when you graph another line. So if I was going to do y equals mx minus 5, all I would do is come to minus 1, minus 2, minus 3, minus 4. I would need a minus 5 as my actual intercept. And then I'd use the same slope. So I'd want my line to be parallel. So there would be my new line right here. Okay. If they say this, y equals the opposite of m times x, then come down to the origin, right? Because I don't have, this one is a plus 5. So come down to the origin and do the opposite slope. So instead of going down 1, right 1, I would go up 1, right 1. And here it is, and there's the line. And I'll switch over to my line tool. So I try to draw a straight line as we go. And there it is. And there's the line. So this is for that one. Okay. If you have a piece of graph paper, that's fine. Might even be easier if you have a piece of graph paper. If you don't, you can just Google graph paper, blank graph paper, and they'll have it there. If you want to print a sheet, you can print a sheet. If you want to do it on the screen and then just, kind of take a screenshot of that and submit it, that's fine too. Okay, there's one. Let's see here. Question 2. It says sketch the graphs. So you can choose. You can plug in points into a table, like an XY table. That's absolutely okay. I'm trying to push you a little bit, though. I'm trying to say, can we use that slope intercept form to find the intercept and then use the slope to find additional points? I think it's quicker. Okay, so I hope you try that on this homework. And again, you can set your scale to be whatever you want it to be. In the one above, each little box is worth 1. For something like this in part C, where you have a 20-to-1 ratio, you might want the X values to go up by 4 or maybe by 5 for each box so that you can fit it on a reasonable grid. Okay. And then question 3 says find the X and Y intercept if they exist. Here's your chance to kind of show that you know how to do that tied back to the equations. Okay. All right. And if you're ever confused, what does intercept mean? It means the value of that coordinate is 0. So if you want to find the X-intercept, that means the Y value has to be 0. If you want to find the Y-intercept, the X value has to be 0. Okay. All right. There's 3. I think I said, 5 through 7? Yeah, 5 through 7. Okay, so 5 through 7. So find the equations in slope-intercept form, identify the slope and the y-intercept. This is asking you to do a little bit of work to get the y variable on one side and the x variable on the other side with all the numbers. As an example, I want you to do the one with the fraction, so I'm not going to do that one. Some of you are like, do the one with the fractions. No, 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 no. I've given you a tip already. If you don't like the things with fractions, you can do something to this to make it easier for yourself. That's up to you. Okay, so if I do this middle one right here, then I could bring the 3x to the other side, and I could bring the 7 to the other side by subtracting. And so I end up with this by just bringing the 3x to the other side. Now I can divide everything by -4. And I have to do it for every term. So my end result would be y equals 3/4 x. And then a negative divided by negative is positive plus 7/4. And that would be my slope intercept form. And then from there, the slope is the coefficient here, and the y-intercept is the last piece. So make it easy on yourself if you can. That's totally up to you. Let's see here. What do we have next? Write the equation of the line. So they're going to give you 2 points. So I already showed an example of that in my video of how to take those 2 points and create an equation. Remember, y equals mx plus b is perfectly fine. However, if it's vertical, a vertical line, you're going to have to write it as x equals something. So if the x coordinate stays the same, you're going to have an x equals. Otherwise, you'll have a y equals mx plus b. And lastly, find the coordinates of 2 other collinear points, means on the same line. Collinear, same line, right? Like cohabitate would mean habitate with, or the same habitation. Okay. Now, if you are really struggling with this, pick any 2 points that you want on any graph. So I'm going to go pick a point here. It doesn't matter what that point is. It really doesn't. And then I'll pick another point going over 2 and up 4, let's say. So 2 and up 4. Okay. So what you do is you can actually say, wait a minute. Maybe you'll get this one by yourself. You could say my slope goes like this. So I went up 4 and I went right 2. So if I want another point on the line, guess what you do? You just do it again. Go up 4, right 2. There's another point on the line. Or if you want, go down 4 and left 2. There's another point on that same line. So use that, right? Think smarter, not harder. If you were in an algebra class, the teacher would say, you have to create the line for this and then plug in additional x coordinates. No, you don't. You don't need to do that. You just use the slope. It's so much quicker. Scott said, right? I hope you see it is, because I mean, to me, it's like algebra could have been so much easier for myself if a teacher would have showed me some of these techniques. All right, let's see here. Find the line containing this point, but parallel to the x-axis. Remember, what is the slope of a line that's parallel to the x-axis, right? What would that slope be? Because then you have a point and the slope, and you can use the equation. I think I said 10 through 12, 10 through 12. Okay, for each of the following, find the slope. This is just find the slope. You could use Scott's super fast technique, the Fallstrom freaking fast method if you want, or you can use the formula. It doesn't matter to me. Once you have the slope, realize you're going to need it for question 12 when you write the equation of the line. Let's see here. Here's lines. They cross these graphs, parallel, find the coordinates of the points. So, yeah, that's that is totally fine if you want to do that one. I don't think I assigned that one though. I think I did 17. 17 was the last one I did. Okay, here we go. All right. Uh-huh. I will demonstrate question 18. I didn't assign it because we actually get to see it in the next few chapters. But here is just working with 2 equations. Can we simplify them? Can we find if there's infinitely many solutions because they're the same line? Can we see if there's no solution because they're parallel? What are our options? Okay, so I did give you a couple of those. Nothing too big. All right. Let's see here. So I do want to demonstrate this one. I think this is kind of a cool one. And so 0, 0, 10, 0, and 6, 8. So I want to show you this one because we're going to see this when we come into the next class. So again, this was not assigned because I knew I was going to do it when I came through it. So the vertices are connected by this, this, and this. Okay, so let me jump out to Desmos because it might be easier to visualize. Okay, so here we go. So I want to just reset this and reload. And now what's great about Desmos is you can actually graph a point. And so they want the point 0, 0. So there it is. It just graphs it for me. You can see right there. And then I want the point, what they say, 10, 0. Okay, so there's the point 10, 0. That one's in blue. And then what was the other point? 6, 8, 6, 8. Okay, there it is in green. So I can just type the points in, it graphs them for me. Okay, now let's see here. 6, 8. Show that the segments connecting 5, 0 and 6, 8. Okay, so let me go back to that. 5, 0. 5, 0 is down here. and 6, 8. Okay, so I'm going to draw that segment in. So I want to go from 5, 0 to 6, 8. There it is. Okay. And let's see, what were the other points? I got to check again. That line's going to stay for just a second. 10, 0 and 3, 4. Okay, so let's see here. 10, 0 and a 0.34. Okay, I see the 0.34. So 1, 2, 3, 1, 2, 3, 4 right there. Okay. And what was the last one? And 0, 0, 8, 4. Okay, 0, 0, and 8, 4. Okay, so go to 5, 6, 7, 8, 1, 2, 3, 4. And this one right here goes back to the origin right there. And if you take a look, look at this. They all intersect at one point. Now that may be like, okay, whoop-de-doo. But what I want to show you is this. If you think about this exterior shape, if I connect the points out here, I actually have a triangle. And the points on the triangle that we went to are known as, oh, I want to fill that in. Could I have filled that in? How do I fill that in? Hold on. There we go. These are the midpoints of the sides. So if you have a triangle, any triangle, and you find the midpoints of the sides and connect them to that kind of opposite vertex, all of those lines are going to intersect at a single point every time. It's so cool. It's like not just a fluke. It doesn't just happen once. You're like, wait a minute, can I move this point out of the way? And the answer is yes, you can. So what I'm going to do though is I'm going to go over here to show you that, to demonstrate that. I'm going to go back to Desmos.com because they have a different tool under math tools. One of the tools is called geometry. And so with geometry, you can actually create line segments, and those line segments could build a triangle, right? And then some of the things that are creations, and we'll actually see how to do as we go forward, is we could find the midpoints. Now, you can do it on a computer very quickly. We'll also do it with the compass and a straight edge to show how the computer did it kind of behind the scenes. And then you can create segments. Let's see here. So I can create segments from the midpoint to the opposite, from the midpoint to the opposite, and from the midpoint to the opposite. And you could see here, right? Can you see it, right? There is a single point in the middle. And what's great with the geometry tools, the technologies, I could click to move a point. And so no matter where that point is, you can see that it's still, all of them still touch at that one single point in the middle. Even if the triangle is very, very, very obtuse, even if it's very, 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 very acute, there's always that one point in the middle where the midpoints touch. That's pretty cool. Now, there's more to it than that. Like I don't know. I get caught up sometimes, so I have to be very careful about how much do I want to get into this. But if you were to create, oops, I got to move my floating face was in the way. Sorry about that. But if you were to create segments that went just to that new point, right? You can, and you could even measure those. And let's see here. No. You could oops, I've clicked over here somehow. Okay. Oh, I got up. Oh, I was on the I was on the polygon tool. So I just built a polygon. Whoops. Okay, so let me go back to my tools over here. So if I look at this segment right here, and I look at this segment down at the bottom, so I'm going to build those segments that just goes to that point. Okay, so now I can see the segment. I can see the segment here. And you could measure the length of these segments, this long segment here to this little segment here. And you might be very interested by what you find because the length that you end up finding turns out to be a constant. No matter where you move these two, the long length to the short length is always a constant. So let's see. I don't remember if it has these tools over here. No, don't want those. No, don't want those. I'll have to check. I don't remember if they have all the tools built in yet. Desmos was still kind of catching up to GeoGebra. And GeoGebra, I know, has all of the tools built in. But this one does not seem to. It gives me the tools translate, reflect, dilate, and rotate. Those will be in chapter 14. I'll just label that as long part. Okay, there's the long part. I can click on this one and I can label this one too, maybe. Maybe that's all I need to do. I need to, oh, I could change the color of it too. I need to do that. Okay, long part becomes red. Okay, there we go. And down here, this will be a short part. I'll go in green. Okay. So there we go. Long part to short part. And so over here, let's see, it's not letting me type that. Stinking thinking. One object selected. Ooh, what if I didn't label it? What if I just said label it? Would it just give me the length? Oh, there we go. Okay, there we go. See, I'll figure that part out. I'll figure out what the heck they're trying to do to us here. Okay, there we go. So watch this. Take a look. 2.78 and 5.56. If you took the lengths and you divided them, you might get a really nice number. And if you change these, it turns out, look at this, 2.5 for one, 5 for the other. Interesting. If I extend this one out, I might be able to get to 6. And if one of them is 6, let's see if I can get it right, 2, 6. Sometimes you got to get really close. There we go. Look at this. What an interesting ratio. And again, you could actually do it for all of these little pieces, but you'll get this ratio every time. And what we'll be able to do by the end of the course is we'll be able to show someone why you get that ratio every single time. So you can get these pieces in geometry that give you a lot more depth, a lot more interesting connections that might actually be able to help you as you're solving other real world problems. So right now in this question in the book, all it says is show that they intersect at a common point. And at that point, they don't even label them. They don't tell you these are midpoints of segments or anything like that. Or this is they say it's a vertices of a triangle, but they don't really connect that idea. And so I wanted to give you a little bit more on that one because to me, that kind of shows where we're going with the class. All right. That's it for now. Hopefully that helps. If you have other questions, please let me know. Off you go.